So as we look through, right, they're going to call these the key features of a graph. So just like a show of hands, like we're just going to go down the list, how many people know or feel very good about x and y intercepts? Okay, about 80%, wonderful. What about linearity? Like they're saying it's a line, so show of hands, like linearity being linear, is that okay? About half, right? What's the other option? Yeah, just nonlinear, right? Continuity, continuous, same thing, show of hands, right? Continuous, what does that mean? So firstly, it'll go on forever in both directions. What else is it going to mean?
You can draw it entirely without taking out the
Yeah, so there's no gaps or holes or anything, okay? Positive, I'm not sure if we understand positive or not. So what about positive? Anyone know what the positives are? Has something, that's going to be the next one more, the increasing and decreasing one, of which way the graph is going. So, like, firstly, do we remember our quadrants?
Yes.
So, right, it goes like this, right? This would be number one.
Yes.
Right, number one, number two, right? All right, so positive. So here's the tough thing about functions. If you're talking about it, then you're talking about the function, and that means you're talking about the y values. If you're talking about where, you're looking at the x values. So where is it positive is referring to positive y values. The where would be on the x's. So then what for you and I, positive means anything in the first two quadrants. Okay, so if you can sketch this in the first two quadrants, then you're saying it's positive there. Anything below the x-axis in the third and fourth quadrant, right, that's going to be negative. Is that okay? So then the increasing and decreasing, just like when you're reading, you're going left to right. So increasing left to right would be something like that. Is that okay? And so then that means decreasing would be in the other direction, right? That'd be decreasing. Is that okay? And then end behavior, same thing, hands, like how many people feel okay with end behavior? Okay, not as many. Those of you that said that you're not feeling good about it, if I talk it through, is it okay? Like as in, is it mostly the symbols that drive you crazy? Does that sound accurate? Those are the symbols. So, okay, so which way then is the positive infinity? Right, it's to the right. Or up, depending on which one you're talking about, right? The x value is positive infinity is over that way. F of x, the positive infinity is up. All right, so then that means negative infinity for the x values is to the left, and then negative infinity for the y values is down. And you got to read f of x as y values, period. Okay? Because you're going to see that all the time. So if you see f of x, or we're talking about it, right? That's the function, f of x, then you're looking up and down because that's y values. Is that okay? All right, so all we got to do is sketch this as close as we can. And the first thing I would look at is the fact that it's linear. So no matter what, it's going to be a straight line. The other thing I would look at after that is any coordinate that they give us. And so they give us two. They give you an x-intercept and a y-intercept. So we're doing your homework. I don't know if you have enough room on these or if you need your own paper. That's up to you. I would, you don't need graph paper, but just try to make a coordinate plane relatively in scale. You want to tie it up ready. And if you can't see, these are going by twos. So that's 2, 4, 6, 8 up here.
This is going 8 graphs.
You're gonna end up drawing 8 graphs, yeah, right. Well, 10, because there's 2 word problems that go with it. All right, so I'm going to put on what we know for sure. We know for sure that the x-intercept is at 2, 0. So I'm going to put a point at 2, 0. This might be a little sloppy for me, right? X-intercept 2, 0. We also know the y-intercept is down at 0, -6. It's almost off my screen. It's down here somewhere. And then like right now, you know it's a line, so hopefully you remember that all you need for a line is 2 points. All right, it's a line, we got 2 points, so we know what it's going to look like. I can do this. Let's do it this way. Now, you get the idea, right? I missed. And so now let's look at the rest of what they're saying. Linear, it's a line, or at least it's close to a line. It's continuous, right? There's no holes. We didn't have to pick up our pencil. It's going in both directions forever. And then they got some more stuff, right? Positive for values of x is greater than 2. Right? So again, we're looking here and going to the right. X is greater than 2. Is the line above the above the x-axis?
Yes.
All right, so that's making it positive. It being the function. It is positive there. Where? Above 2. Okay, and again, that's the tricky part of functions. When I say where, you should be answering with x values. If I say it or the function, you're answering in y values. Right? And then they have, that's the only thing they gave you on positive. It's increasing for all values of x, right? As we're going left to right, is it going up and up and up?
Yes.
So then it's increasing that whole time. And then finally at this last end behavior, as x goes to positive infinity, right over here. As x going to positive infinity, it says y should be going to positive infinity, right? It's going up. And then it says, and as x goes to negative infinity, way out here, that f better be going to negative infinity, right? It is going down. So like all these things on here, right, we check them off. We got it. That's the graph what we wanted. Is that okay? If you look at number 2, I don't know if we need to do any more of the linear ones, but if you look at number 2, they only give you one coordinate. So you can't make it as accurate, but that's not what you're trying to do. You're not necessarily making these perfectly accurate. You're just getting them for the information that they give you. You're making some kind of sketch that fits all of the parameters. So do we want to do another one before we do a nonlinear one?
Yeah.
All right, pick one.
2.
Just 2. Okay, so let's look at 2. Let me erase this. Oh man, look at that. That's not good. What's happening there? That's not what I wanted to have happen. No. Well, that's it. All right, so again, so it tells us it's what, linear or nonlinear? Linear, okay, so it's going to be a straight line. They gave us an x and y intercept. What are they? 0, 0. Okay, so that's the only thing we can get, right? 0, 0 right here. It's continuous again. And then, what I would suggest is figuring out which one of these makes the most sense to you. The positive and negative might be a little confusing because we're going back and forth from the x to the y. Right? It's saying positive for values where x is less than 0. Right? X is less than 0 is on the left. Okay, so they want it to be, positive there. So what quadrant is that? So we're on the left, right? X is less than 0, and we want to be positive. So second quadrant, is that okay? So we're coming down from the second quadrant, because it also says that we're decreasing for all values of x. So left to right, it's going down. Everything's going to be left to right, just like when you're reading. Okay? And then it says it's negative for values bigger than x. So, right, bigger than x is on the right. What quadrant is it going to have to go in then? The fourth. Do we have any real other information? Okay, so as long as you are in the second quadrant, going through the origin to the fourth quadrant, then you have everything that we need. And right, you can look at the rest of it. It's decreasing for all values of x. The end behavior as x goes to positive infinity, again out to the right, the y values better go to the negative infinity, which it is. And when x goes to negative infinity, it says y better be going to positive infinity, which again it is. Is that okay? We can do one more, we'll do a non-linear one. So 5, 6, or 8. 5, 6, or 8. I don't care which one do you want to do? Which one are we doing? 6. All right. Again, I would look at if it's linear or nonlinear first, okay? So then at least you know what kind of, if it's linear, it should be super easy. It's definitely continuous, and then they give us a bunch more information. But I would always start with coordinates because those aren't going to change no matter what. So they give us 2 x-intercepts. What are they? All right, so negative 3, 0 would be here. And then what, 2, 0? Should be there. All right, we know those for sure. They give us a y-intercept. Right, 0, negative 4, 1, 2, 3, 4, right here. We know those. What else do we know for sure? Say it again. It's continuous for sure. We got another coordinate on there that they kind of give us. Yeah, so it's the same place as the y-intercept. So, it might be a good idea for you to, say something about that. That's also the minimum. So what does that mean for you? How do you spell minimum? Like that? Is that right? Minimum or minimum? 2 I's? Minimum. Yeah, mini. Yeah, okay. Can I just maybe, why is it, I don't want that. What if I just did, well, it's not going to erase now. Mini. Mum. All right. So what's that mean again? That's the lowest point, so nothing better be going below. So the rest of this, we know that it's not going to go below that, okay? All right, so we got a bunch of stuff going on. Positive, okay? So values, right? It's positive, it being the function. So we better be above the x-axis, where? Less than negative 3. So here's negative 3. So we're positive over here. Is that okay? Okay? And then it says, and greater than 2. So again, we're going to be positive over here, yeah? All right, so then I'm going to put those in right now. Right, so I know it's doing something like this right now. Yeah? Since there's no other points, what's it saying about the end behavior? What's it say when x goes to negative infinity? What's y supposed to be doing? Going to positive infinity. So it's heading in the right direction then. All right, so I'm just going to put some arrows in. What about when it's going to positive infinity? Positive also. Is that okay? I'm doing your homework right now. Who does that? All right, it says negative from values negative 3 to 2. Huh? What'd you say?
Oh, you asked me to do my homework instead of this
Uh-huh. Is your sister that does it usually? So is that?
Yeah.
Huh. Well, there's answers to every question, isn't there?
No.
All right. Right, I'm doing your homework. I do more of your homework than some of you guys do, right?
Yep.
I know. It's fine with me. I wonder why it gets hard, right? Learning is an interesting thing, right? You actually have to try. It's weird, right? Showing up. Yeah, I didn't put my stand up, my orange slice stand, right? I didn't get it out yet. All right, everybody gets an orange slice for showing up. Good job, huh? All right. You guys football fans. Remember James Harrison? You remember that guy? You know what happened when his son lost in football and they gave him a trophy? Have you ever heard this story? They were going back to the car and his son came with a trophy. He's like, "What is that?" He's like, "Oh, they gave it to him." He's like, "You take that thing back. You didn't win. Take it back." Right? He's got Super Bowl rings. I don't know. Maybe he knows what he's talking about. All right? Yeah, I don't know how old he was. It might have been pretty harsh. I don't know. It might have been 6. I've been like, I don't know. Yeah, that's right. Otherwise, he goes up and just sits there in class without doing anything, right? Like nothing. All right? Blaming other people for his situation. It's amazing. Anyway, what else we got here? It's decreasing all the way to x equals 0. Right? Decreasing all the way, right? It's decreasing here, left to right. Once it gets to 0, right, it starts increasing. Right? Is that okay? All right, flip it over. Right, number 11. Right, we got 2 different functions here. They want to compare the key features. Key features are the same things that we were just looking at. You're not going to be able to compare them all. Okay? But let's look through some of them. Right, f is a graph there, a linear function, and g is a table. Can we tell if they are both linear? We can start with that since we know, right, everyone knows that f is linear. How can we tell if g is linear? What is it again? Find the slope. Okay, and so I don't know that we have to have this slope for sure. I mean, that'd be nice, but we better make sure it's actually linear first. So how can we tell just by the table if it's linear?
All y-axis is, there's no repeating on the y-axis.
I think you just told me what a function,
That's a function.
or maybe a one-to-one. How can you tell if by the table if it's linear? Well, we'll get to that here in a second. But just how do we know it's linear? Like what happens with like if you're looking at f there, is it growing faster and slower or is it constant? It's constant. So that's what a linear function does, right? It grows at the same pace or it decreases at the same pace all the time. So then how can we look at the table and figure out? If it has to grow or decrease at the same rate. How could you tell?
Actually, it is.
How can you tell?
It's going up by 3 on the y. And
All right, yeah, so he's going down, right? So the x is going up by 1 every step, right? So the only way it's going to be linear is if g of x or y is going up at the same amount. It doesn't have to be the same thing. It has to be the same amount. So -4 to -1 is up 3. -1 to 2 is up 3. 2 to 5 is up 3. 5 to 8 is up 3. So then is it linear?
yes.
All right, so then they're both linear. So that's a good place. We can start with that. Right? So this is the kind of stuff you would want to write for this. Both linear. Now tomorrow we're going to start getting more involved in this, but how do we find slope? Well, we're not going there. We're going up there next. Yeah, so he gave we're doing that. That's starting tomorrow. So right here's the slope formula. Right? Quinn was saying this, right? Is that what you said? Right? Hopefully you've seen that before. So if we know it's linear on G, right, we could just plug in some values. Does it matter which values we plug in? No, as long as you do what?
Plug that Same Y,
Yeah,
or same X.
yeah, so whatever you pick for the Y one, you better pick that corresponding X, or otherwise you're jacking it up, right? All right, so Joe, pick a Y and an X, or an X and a Y for us.
-2, -4.
All right, so then -2 and -4, all right? And then we're subtracting. Gabe, pick another one.
1 and 5.
1 and 5, right? The X value, 1 and 5. Right, -4 minus 5 is -9. Right, -2 minus 1, that's -3. So then that one has a slope of 3. What about do you have to do the same thing for the graph? Do you have to do the same thing for the graph? No. Can you do the same thing for the graph? Sure, you could. What's the easier way to do it if it's graph? Rise over run, count up and over, right? So go ahead and look at that. Is it a positive or negative slope? Positive, because it's increasing, right? Positive slope. Right, so this is the slope of G. This is the slope of G. And so the slope of H would be 1 over 2. Is that okay with everyone? Right, rise over run, right? Up 1 over 2. Slope is only the most important thing in math, right? Well, at least through calculus. So that's why you guys have been doing slope for seems like forever, right? Like you guys probably started in maybe 6th, 7th grade. Yeah, the reason they keep hitting this stuff is because that's how you can go further in math, right? Slope is like the biggest deal there is. Right, that's how you find miles per hour. That's how you find any rate of change. Right, that's important. Right, if you got an oil well and you're going to drain it, you better know how much is coming out of it and how much was in it so you know how long you have it. Right, so important stuff. Change it. Rate of change. All right, so then which one of these is steeper? Because we could also say this. Which one's steeper? G is steeper, right? It's going up 3. So slope of G is steeper. That'd be a comparison. All right, so that was a good place to start. That's a lot of information. What about x-intercepts on 11? Right, F. What's the x-intercept there?
0.
2, 0. Do we have an x-intercept on G?
No.
No, we don't, right? So, I mean, you could graph it and you could tell me something about it, but if we're just going off of what they gave us, let's go to the y-intercept. Is there a y-intercept for our F? What is it? 0, -1. Do we have one for G? What is it for G? 0, 2. So then you could say, right, if we're comparing it, this is what they want you guys to do. Right, G of X has a higher or greater, however you want to say it, higher / greater y-intercept. Right, where you're pairing the two things. Is that okay? Right, we've already talked about that they're aligned. Where are they? Is one of them not continuous? Because clearly the line is. I mean, you can just draw a line through those points, right? It should be continuous. Right, where does it start becoming positive? At the x-intercept. So I guess the way we did the x-intercept, we don't know where it becomes positive for the G. We decided they're both increasing. And what about the end behavior? We should know from the slope if they're both increasing, right? Right, as x goes to positive infinity, so does y on both of them. What about for negative infinity? They both go to negative, yes. Is that okay? that okay? Right, because the answer is either yes or no. And if it's no, then you gotta ask. All right, so